Hello, my dearest students. We are working through this chapter, about to finish it actually, and we are on Chapter 3, Lesson 12, 3.10, and this is on page 227. Page 227 of our MyMath books. We're still pushing through division, and today we're gonna learn how to interpret the remainder. So what does that remainder mean? That's kind of what we're thinking about today, is what does that remainder mean? So let's take a look at these. These are gonna have a lot of different word problems. So it says a state park has 257 evergreens to plant equally in 9 areas. How many evergreens are planted in each area, and what does the remainder represent? So we're going to divide 257 by 9. So they've already written it out. Remember, the first number always goes inside the house. 257, that is our dividend, and the divisor is 9. 257 divided by 9. Okay, so let's go ahead and divide this, and we're going to see, can 9 go into that 2? No, it can't. So remember, we can put the 0 and multiply it out, or since it's our first number here, we can just lump these together and take a look and see 9 into 25. So 25 divided by 9. Well, I know 1 times 9 is 9, 2 times 9 is 18, 3 times 9 is 27. That's too big. So it needs to be 2 times. So let's draw that 2. Now we multiply. 2 times 9 is 18. Now we subtract. Remember, if I have 5 apples, you cannot take 8 away from them. I have to borrow. So this 2 is going to become a 1, and this 5 becomes a 15. 15 minus 8 is 7. Now I already subtracted. I bring down my next 7, and I start over again. So 77 divided by 9. 77 divided by 9. Well, that's going to be, let's see, 9 times 10 is 90. 9 times, let's see, 6. 9 times 6 is 54. I'm trying to think of my 9 facts. 9 times 7 is 63. 9 times 8 is 74. Ooh, 9 times 8 is 74. Is that right? Mrs. Bodell is checking her work. No, it's 72, isn't it? Mrs. Bodell's brain, it's not working. It's 72. So 9 times 8, that's going to fit right under 77, is 72. 9 times 8 is 72. And I subtract. 7 minus 2 is 5. 7 minus 7 is nothing. So the remainder here is 5. So we have 28 with a remainder of 5. So what is that 5? So we're putting trees into 9 groups. So we've got these 9 groups, like maybe forest 1 and 2 and 3, 4, 5, 6, 7, 8, 9. There's 9 of them. And we divided them up, and 28 of them go in each one. But then what happens with this 5? Well, it's less than 9, so we couldn't divide it up evenly. That's why the remainders always have to be less than that number. So there's 5 evergreen plants left over. So the park plants 28 evergreens in each area, and there are 5 left over. You can't divide those 5 equally into 9 groups because it wouldn't be fair. If there are 9 people in your family and your mom only has 5 pieces of candy, it wouldn't be fair to give 1 to the first 5 and not to the others. So we cannot divide it equally. That's what makes it the remainder. Let's do a few more of these problems. Let's go on to page 2. Example number 2. Okay. This thing's driving me crazy. There are 174 guests invited to dinner, and each table seats 8 guests. How many tables are needed? So we're going to divide up these 174 guests into tables that seat 8. So this one's going to seat 8, and then one here is going to seat 8, and one here. And we want to make it as even as we can. So that's why we're going to divide 174 divided by 8. So we're going to place that first digit. So can 8 go into 1? No, it's too small. If you want to go ahead and put the 0 there and multiply it out, you can. But since this is our first digit here, we don't have to do all that extra work. We can just grab onto the next one and make this 17. How many times does 8 go into 17? Well, let's see. 8 times 1 is 8. 8 times 2 is 16. 8 times 2 is 16. So 2 times 8, we multiply now, is 16. I subtract. 17 minus 16 is 1. Bring down the 4. How many times does 8 go into 14? Just once, because 2 times 8 is 16. 1 times 8 is 8. So 1 times 8 is 8. 14 minus 8. If you don't know that, you can count up. 9, 10, 11, 12, 13, 14 is 6. The remainder is 6. So what's happening with this remainder? So let's see. So the remainder is 6. That means that there's 6 guests left over, which is not enough for a full table of 8. But they also need a table because it wants to know how many tables are needed. So these 6 guests don't just leave the party. They're going to come to this dinner, but they need a table. So we have 21 full tables, right? 21 full tables. And how many tables are these 6 people going to take up? They won't be full, but how many tables do they need? Just one, right? Because there's 8 chairs. 6, 7, 8, and they're only going to fill 6 of them. But they still need a table. So in this case, the number of tables needed is 22. The number of tables that they need is 22. So when we're talking about tables, we have to make sure that we get a table for that group of people. So we have to really pay attention to what they're asking for. We're not asking for how many people can fit at each table. We're asking for how many tables do we need. Let's do another example. A tent is put up with 7 poles. How many tents can be put up with 200 poles? So we're going to divide 200 divided by 7, and then we're going to interpret the remainder. So let's use our sheet here. 200 divided by 7. So 7 can't go into 2, but if you want to do this way, we can. 7 times 0 is 0, subtract 2, and now you see I have the exact same answer of 20. How many times can 7 go into 20? Let's see. 1 times 7 is 7, 2 times 7 is 14, 3 times 7 is 21. That's too big, so it's going to be a 2. 2 times 7 is 14. Now I subtract. Can I take 4 apples away from 0 apples? No, I have to borrow. This becomes a 1 and this becomes a 10. 10 minus 4 is 6. Bring down my 0. How many times can 7 go into 60? Well, 7 times 9 is 63. 7 times 8 is 56. That's just under it. 8 times 7 is 56. Subtract. Can I take 6 apples away from 0 apples? No, I have to borrow. This becomes a 5. This becomes a 10. 10 minus 6 is 4. So my remainder is 4. So now that's the math part of it. So I know that there's 28, remainder 4. 28 what? We're talking about tents. How many tents can be put up? So I know that 28 tents. Well, our remainder is 4. There are 4 poles left over. Is that enough to make another tent? Is 4 poles enough to make another tent? Well, it tells me I need 7 poles to make up a tent. So can I make a tent with this? No. So how many tents can I put up? Just 28. I can't add another one because I don't have enough poles. Those poles are just going to sit on the side. So for this one, the remainder I just kind of ignored it because I can only put up 28 whole tents. We have to pay attention to what they're asking. And you have to think, can I put up a tent with 4 poles if it says I need 7? Well, no, those are just going to lay on the side. You'll put them back in a bag and maybe use them for your next trip. Okay, let's keep chugging along, my friends. Number 2 says there are 50 students traveling in vans on field trips. Each van seats 8 students. How many vans are needed? Okay, so we've got 50 kiddos. 50 kiddos. I'm only gonna draw one. 50 of them. And each van, so here's my van. Boo-doo-doo, this is the ugliest van. Okay, this van seats 8 kids. Okay? How many vans do we need to fit all these kids? Now, let's just think this through. One van wouldn't be enough, right? Because I only said 8. What if I have 2 vans? What if I have 2 vans? Let's just think. How many total students would I be able to take with 2 vans? 16, right? Let's try 3 vans. These are getting worse and worse as we go. Also holds 8. How many can I put how many kids am I holding all together now? Well, now I have 8 plus 8 plus 8, or 24. That's still not enough. So what if I do 5, 6, 7, or 1, 2, 3, 4, 5, 6, 6. What if I do 6? Now let's see. We've got 8 in each one. So 1, 2, 3, 4, 5, 6 times 8 is what? 6 times 8 is 48. So do I have enough? Do I have enough seats? No, there's 2 kids left over that need a seat. So aren't we going to need another van? I think we are. We're going to need one more van, even though there's only 2 kiddos in that last van. We're going to need something for them to ride in so that we can take them all. So we need, how many vans do we need? 1, 2, 3, 4, 5, 6, 7. We need 7 vans. And let's take a look at this if we did the problem, instead of doing it with drawing pictures, if we did it this way. We've got 50 students and 8 fit on each bus. We need all the students accounted for. So 8 can't go into 5, it's just 8 into 50. So I know my math facts, 8 times 6 is 48. 50 minus 48, I have to borrow 2. So I have 6, remainder 2. 6 whole buses and 2 extra kids that still need a ride. So how many do I need? I need to do 6 plus 1 bus. So 7 vans or buses is what we need for that trip. So we have to look at that remainder and decide, what are we supposed to do with that information? Let's look at this one. How many payments of $10 would it take Samuel to purchase the scooter shown at the right? So he wants to buy this scooter for $79, and he's going to pay $10 a time. So he pays $10 and he pays $10, that's 2 payments, and he pays $10, that's 3 payments, and he pays $10, that's 4, $10, that's 5, $10, that's 6, 10 plus 10 plus 10 plus 10 plus 10 plus 10, that's 60, plus $10, that's 70. He needs to make another payment, right? So how many payments does he have to make? 1, 2, 3, 4, 5, 6, 7, 8. He has to make 8 payments to actually cover the cost of 79. He has to make 8 whole payments. If we divided 79 divided by 10, and we actually haven't done a 2-digit number here in the divisor, but we will next week, we would see that it fits 7 times. 7 times 10 is 70. With 9 left over. So he made 7 payments, but he didn't quite get it. There was a remainder. He still owed part of it. So he has to make 8 payments. 8 payments is what he needs. Muffins. Mrs. Hodges made 144 muffins for a bake sale. That sounds lovely. She put them into tins of 5 muffins each. How many tins of muffins can she make? So she probably packed them up in these little cute boxes for people to buy at the bake sale. And they each have 5. So we're going to divide 144 divided by 5. 144 is how many total muffins, and we're going to divide them into groups of 5. 5 can't go into that 1. You can multiply it out, subtract, bring down. Oops, that's a 1. I get my 14 there. How many times does 5 go into 14? Well, 5, 10, 15 is too big. 5, 10, 2 times. 5 times 2 is 10. 14 minus 10 is 4, or 4 minus 0 is 4. 1 minus 1 is nothing. I bring down a 4. How many times does 5 go into 44? 5, 10, 15, 20, 25, 30, 35, 40. 45 is too big. So 40, 8. 8 times 5 is 40. And now I subtract. 44 minus 40 is 4. That's a really ugly 4. So my remainder is 4. So I have 28 with a remainder of 4. Let's think about this. So my answer that I got with math is 28 remainder 4. Now, what were we asking? This is how many tins she has that have 5 muffins. She's got 28 just like that. Can she make another muffin tin and sell it in the 5-pack? She only has 4 left. So she can't use that. She has to like give those to her friends or something, or give them to her kids or grandma. So she can only make 28 tins. She cannot use her remainder. It's not enough. It's not enough to sell at the bake sale. She could give them away, but she can't sell them in the 5-packs. Okay, last one, you guys. We're going to stop here. How many 8-foot sections of fencing are needed for 189 feet of fence? So you could do this. You could go like this and draw a little fence and say, okay, that's an 8-foot section. Well, let's call it, yeah, it's 8 feet. Let's go like this. We'll measure it. Boop. And then here's another one, 8 feet long. This is 1. Now we've got 2. Now we've got 3. Now we've got 4. Now we've got 5 sections. And we know that right now our total feet is 8. 1, 2, 3, 4, 5. 8 times 5. We're at 40 feet right now. But that's going to take us a long time. You can do it that way, or we can just go like this. 189 divided by 8. 8 can't fit into 1, but it definitely can fit into 18. How many times does 8 go into 18? Twice. 2 times 8 is 16. I subtract. 8 minus 6 is 2. I bring down. 29 divided by 8. How many times can 8 fit into 29? Well, 8, 16, 24. 8 times 4 is 32. Too big. 3 times. 8 times 3 is 24. I subtract. 9 minus 4 is 5. So there's going to be 23 whole sections. So imagine like this, like if we kept going, and drawing pictures, you guys, is a great way to try and figure that out, because we've got a fence and we need 23 sections to get us almost there. But does it get us to 189 feet? Let's check. What's 23 times 8? Well, we're checking our answer here. 24, 16, 17, 18. No, because of that remainder. We only have 184 feet. So your fence right now is going almost all the way there, but it needs to get to that wall, and this is missing. What's missing there? What's missing? This section, right? The remainder is missing. We need this portion of it. We need these 5 extra feet. So we actually need another section, and then maybe they only sell them in 8 foots. So it would go over, but you'd have to take your saw and cut it and cut that off. So we need a section here to be cut. Oh my gosh, you guys, I was blocking it with my head. We need an 8-foot section here to go over our length, and then we cut it off. So we need to add one more section to our total. So instead of 23, we need 24 sections of fence. 24 sections. And sometimes, you guys, if you don't draw it out, like drawing the muffin tins or drawing the fence, it doesn't fully make sense, but you needed to cover 189 feet. And so if you didn't buy this last section to chop off that end and saw it off with your saw, you would have this hole right there in your fence. It wouldn't be done. So we need 24 sections to cut that off. Fantastic work, my friends. This is good thinking math. I hope you've had a fun time doing it. This is real life math. Mrs. Bodell was actually building stairs at her deck, and we had to do something really similar to this. So this is math that you're going to use all the time, and I hope you guys had fun. If you had any questions, let me know.